Hello, this is Scholar Stack doing some math today. In Algebra 1, we'll be graphing quadratic equations. So we have the form ax squared plus bx plus c. That's standard form for quadratics. If your a value is positive, then it opens upward. If it's negative, it opens downward. If your a value is bigger than 1, then it's tall and skinny, also known as a vertical stretch. If it's less than 1, so this would be kind of like a fraction, like 1/4, a quarter, a third, bigger than bigger than 0 but less than 1. Then this is called a vertical shrink, where it becomes wide. The axis of symmetry, so if, let's say we have a parabola here, the axis of symmetry is the line that cuts the graph in half into two symmetrical parts. It can be found using this equation here, x equals negative b over 2a, where a, b, and c are in the equation. We can use this to find our vertex. So remember, this point here, the lowest or the highest point, is our vertex, and we can use the axis of symmetry to find our vertex. Let's graph this. Okay, so first thing we probably should do is just label our a, b, and c. A in this case is -1, b is 4, and c is -1. A is the value in front of the x squared term, so that's a negative there, so -1. B is the number in front of x, so it is 4, and then c is the constant. So we want to decide whether the parabola opens up or down. So that looks at our a value. Our a value is negative, so it opens down. Find the axis of symmetry. So we have the equation x equals -b over 2a. Okay, so x equals -4 over 2 times -1, which is -4 over -2, which is +2. So we have the line x equals 2. This is the axis of symmetry. Axis of symmetry. Okay, now we got to find and plot the vertex. We're going to go ahead and substitute x equals 2 into the equation. So negative, and then parentheses x squared, so 2 squared, plus 4 times 2 minus 1. That'll give us 2 squared is 4, and then the negative outside makes it negative, plus 4 times 2, which is 8, minus 1. -4 plus 8 is 4, minus 1 is 3. Okay, so my vertex is at 2, 3. Okay, this is my x, this is my y. So we're going to go ahead and plot that. 2, 3, so right here. This is the vertex, and we know it's opening down. Okay, so now we got to plot 2 points that are not on the vertex. So I usually choose 2 points that are next to the vertex. So 1 and 0 is good. So 1 and 0. So I could use 3 and 4 or 1 and 0 because it'll be symmetrical. So 1 and 0. Here we go. So if I plug in 1 of the equation, I'll get -1 squared, which is -1, or 1 squared times -1, which is -1, plus 4 times 1 minus 1. So I'll have -1 plus 4 minus 1, which is 2. Okay, so I got 2 there. And then I'm going to plug in 0. 0 is a lot easier to work with. 0 plus 0 minus 1. So 0 plus 0 minus 1 is negative 1. Okay, and then we're just going to plot those points. So 1, comma 2, 0, comma, negative 1. Okay, draw that side. Okay, and then just make it symmetrical. 3 would be also 2, and 4 would be negative 1. Symmetric. Now we're done. When you're drawing these, make sure most teachers want 5 points usually. So let's do another example. Graph the function. So A is 4, B is 8, C is 3. So step 1, does it open up or down? Opens up. A is positive. Step 2, find our axis of symmetry. X equals negative b over 2a. So this will give us negative 8 over 2 times 4, which is negative 8 over 8, which is negative 1. Okay, step 3, substitute into the equation. So 4 times negative 1 squared plus 8 times negative 1 plus 3. This will give me 4 times positive 1 minus 8 plus 3. So 4 minus 8 is negative 4 plus 3 is negative 1. So my vertex is negative 1. That was my x value, and my y value is also negative 1. So we're going to start here. And we'll just draw in our axis of symmetry, because we got to make it symmetrical. And then step 4, let's create a table, x, y, but we just need to choose 2 points, and I'm going to choose 0 and 1. Okay, when I plug these in, I'll get 3, and I'll get 15 for this one. So 0 and 15, and then go to the other side, make it symmetrical, draw RU, done. Okay, tell whether the function has a minimum value or maximum value. If it has a minimum value, it's opening upwards, because this point here would be the smallest. So this is when A is bigger than, A is positive. If A is negative, or A is less than 0, a maximum value will be created, because it's opening downward. So because our A value is positive, we have a minimum value. Now how do we find it? Okay, we find it by finding the axis of symmetry. X equals negative b over 2a. Because that'll tell us in the x-coordinate where that location is, because the axis of symmetry goes through that point. So x equals negative b over 2a, a is 5, b is negative 20, and c is 17. So I'll get opposite of negative 20, which is positive 20, over 2 times 5, which is 10. So 20 divided by 10 is 2. Okay, we're going to substitute x equals 2 to find our minimum value. Alright, so not only will this find our minimum value, it will also find us our vertex if we ever wanted to graph it. So 5 times 2 squared minus 20 times 2 plus 17. So 2 times 2 is 4, times 5 is 20, minus 40 plus 17. So we'll get negative 3. So my answer, this is my value, is negative 3. If we were looking for the vertex, it would be 2 comma negative 3. Say this number here is my minimum value. It would be my maximum value if it opened downward. Alright, let's do this again. A is negative 1/2, B is 6, C is 8. We know that this is a maximum value because A is less than 0. It's negative. Okay, now we're going to use the axis of symmetry to find our value. So negative b, so negative 6 over 2 times a, which is negative 1/2. That'll be negative 6 over negative 1, which is positive 6. We're going to substitute this into our equation. So negative 1/2, 6 squared plus 6 times 6 plus 8. So this is negative. This is 1/2 of 36, so that's 18 plus 36 plus 8, and we'll get this equal to be 26. So my maximum value is 26. If I want to look at my vertex, it's 6, 26. Hopefully this helped you out. Have a good day.